All right, recording. Okay, so once I find that x equals -1, I go back up in here and I'll find 2x plus 4, because -4 times -1 is +4, equals 14. All right, now this is the two-step equation. How do I solve for x? Subtract 4 and divide by 2. So what is 14 subtract 4? 10 divided by 2?
5.
5. So that means I have a 5 and a -1.
Right.
So -2 times 5, -10, -6 times 1 plus 6, what's it equal? -4. And so therefore it checks and I got the right answer. And so the answer is x of 5, y of -1. That's where those two lines cross. Now, because all of that is technically Algebra 1, and you now are beginning to remember, oh, I've already done this. Right? Okay. All of that's going to work the same. Right? So I don't want to spend your time talking about that skill, because that's something you should remember, unless somebody has a question about it right now. Okay? So let's look at this one real quick. All right? When I add these two together, what do I end up with? 0 here. What about these? -8y equals. Now they're set up really nice because I'm going to have a negative because the 38 is bigger. It looks like 24.
Yeah.
So what does the y equal?
Oh, +3.
+3. And so then how do you find out what the x is?
So then you put +3
Right.
into y.
You replace it. So this says -8x, and if it's +3 minus 30 equals -38, add 30, and I get -8 at, -8x equals -8, so x is equal to 1, and therefore a 1 here, and a 3 here. 8 plus 6, 14, checks. Okay? Alright, so that's how that goes. Alright, now, how often do simultaneous equations, how often do they hit whole numbers only? And the answer is only in practice, not in reality. Most of the time, the values will hit at non-whole numbers, which are called rational numbers. It'll be rational, but not a whole number, and so the result is going to be a fraction. Okay? Now, if the result is a fraction, that means the math that we're doing right here is not going to be pretty. Right? So there's another way to do it. Okay? You only remember this way because we just started it.
We did it this morning.
Yes, that's right. Okay, now I'm supposed to have a blank paper here. And I do. Okay? Now, so what we're going to talk about is called Kramer's rule. It's a system of equations problem. All right? And in order to do Kramer's rule, we're going to pick a skill that comes from matrices. Now, matrices is something that you're going to get a little bit later, but it's very helpful here. Now, so what happens in a matrix is if I have several numbers, and I'm just going to pretend, let's do it this way, 2, 4, 6, and 5. Now, what happens on a matrix to solve this for a number? These are not absolute value marks, by the way. This is a matrix, right? And a matrix can have different sizes. This happens to be a 2 by 2. Okay, we're going to find something different. Look. Now, what happens is that you take the product going down, and then minus the product going up.
Yes.
Product going down minus the product going up. Okay? so in this case, what will be the product going down? 10. So this is 10 minus 24, which equals negative 14. Okay? All right, simple, right? Now, here's what happens in real life for algebra students. They forget the minus.
Yeah.
They forget the minus. So let's do another one. Okay? Now, what's the first two numbers that I get the product of? Negative 2 and 10. How much is that?
Negative 5.
Negative 20, because we're going to multiply, not divide. Okay? Now, all right, what's this word?
Minus.
Minus.
Negative 6 times 5.
All right, what is negative 6 times 5? Negative 30. And so if I wrote it like this, all right, I don't do it that way. I write the 30 and then put the negative sign like that. Right? Because subtracting a negative is the same as adding a positive. Right? So now, what will be the determinant for this matrix? It's going to be what? Positive 10, isn't it?
Yeah.
Right? Okay? So, those are the simple part of what you need. This is the skill. It's the product going diagonally down minus the product going up. Sometimes the numbers are positive, sometimes they're both positive, sometimes one's positive, one's negative. Okay? Alright, but that's how that works. Alright, question about that part. Okay, now, how's that going to help us? Okay, here's what's going to happen. We need to know what x equals and what y equals. And it's going to be a fraction. We're going to have a denominator, and then we're going to have a numerator for the x and a numerator for the y. Now, what's nice about this, it's the same denominator in both cases. Okay? All right? Now, let's take two equations and let's try to figure this out. All right, if I take 2x plus 3y equals 18. And I take 4x minus 2y equals 12. Okay? The denominator of the place where these lines cross is the matrix that uses the x and the y's. So, what do? I take the diagonal. 2 times negative 2. Negative 4 minus 4 times 3. 12. Alright, what is negative 4 minus 12? Negative 16. Because they're both the same, I know that they're both negative 16. And what I do is I put the math on the first one, I solve it in my head, and then I go ahead and write it down. Okay? Now, this is the harder part. We need another matrix that's up here. Alright, we're going to take these two things that are the answers, and we're going to replace them where the x is. So that's going to make this 18 and 12. These two stay the same, 3, negative 2. That will replace the x, so that'll find the x. The other one, we'll take the 2 and the 4 and replace the y with the 18 and 14. Alright, what I did is I made a matrix. Now, what happened to this first matrix which got me the negative 16? I replaced these two numbers that were the answer, the C. I replaced the x coordinates, x coefficients, with the 18 and the 12, and I made a matrix that looks similar to this except it has different numbers.
Yes, that makes sense.
Right? Then, to get the y, replace these two y values with the 18 and the 12, and I make another matrix. All right, now we have to do the same thing. How do I get the value here? 18 times negative 2. All right, negative 36 minus 12 times 3. What's 12 times 3? Negative 36. Now, negative 36 minus 36 is negative 72. Now, negative 72 over negative 16 is the value for x. All right, is this divisible? I think it is. Somebody in your calculator. Huh?
Negative 72 and negative 16.
Yep.
I'm not trying to put that button. 4.5.
4.5. All right, so the value of x is 4.5.
Yes.
All right, now how do we find the value of y? We got to get a different denominator. So what is 2 times 14? 28. Now what comes next? Real important. Minus 4 times 18. That's 72. 72, 40, and 32 is 72, right? Okay, so 28 minus 72, I can't do that one in my head, so I'm going to say 28 minus 72 is minus 44. Now I know they're both in the 4 times table, right? So negative 44 divided by negative 16 is 2.75, which is 2 3/4, right?
Yes.
So 2.75 is my y value. And if we wanted to check, we would put in the calculator 2 times 4.5. How much is 2 times 4.5? 9 plus 3 times 2.75. 825. Then I made a math error someplace. Because the total should be 18.
Wait, what?
Did I make a math error? It's supposed to have worked. Anyway, we did the math. We did the math correctly, but the math didn't work. Right when we checked it, it didn't work.
Null set. Null set?
No, it's not the null set because the two slopes are different. So the lines have to cross. But I don't know why it didn't work. I made a math, or we made a math error someplace. Let's go back here. 28. What's 4 fixed? 72. 72 subtract 28 is negative 44. Weird. Okay, all right. Because now this is one thing, if you ever become a math teacher, this is the one risk of doing a problem on the fly, right? And not working it out beforehand and having a plain one is, I've done something wrong. You haven't. I've done something wrong, but I don't know where it is, and I don't want to take the time to find it. Okay? But how do I know that those are the wrong answers? Because when you plug them into here, it didn't give us 18.
Right.
Right? Okay? So, all right, but let's go back and we're going to try a couple of other problems. Okay, do you have your math books?
Yes.
All right, get your math books open. I'll tell you what page in just a second.
117.
I'm going to go to page 124. I'm going to go to page 124. Now, this is section 4.3. Now, on page 124, we're going to look at problem 1. 2x, 5x. plus 2y equals how much?
4.
Help me out, equals 11. And then x plus y
Equals 4.
plus y equals 4.
Yeah.
Okay, now, this particular problem could be solved in a number of ways. Okay, I could replace the x with 4 minus y. If I wanted to, I could multiply the bottom by -5 and then add these two together, or I could multiply the bottom by -2 and add those two together to get 0. I have a number of ways, but what we're going to do is we're going to practice using Kramer's rule. Okay? Now, first and the easiest part, how do you find the denominator for x and y? How do you find the denominator? I've already told you. You take these right here and find the determinant. So it's 5 times 1, which is 5, minus 2. Minus 2. So that makes a denominator of 3. All right? We're a third of the way done. Okay? Now, to find the x, I got to replace these two with 11 and 4. I find it easier to just rewrite it. Okay? Now, all right, so how do I find the value? 11 minus 6.
8.
11 minus 6. Oh, 11 minus 8, I'm sorry. 11 minus 8, which is 3. What's 3 divided by 3? 1. So that means my x value is 1. All right, now let's do the same thing. If I use 5 and 1, and then 11 and 4, all right, what's my determinant over there? 20 subtract 11. What's 20 subtract 11? 9.
Oh, we did this one.
What's 9 divided by 3? So, all right, so now let's do this. 5 times 1, because my x is 1, 5 plus 2 times 3, 6. 5 plus 6 is 11. So it works.
Every plus y equals 4.
Okay? All right, now, Kramer's rule for a 2x2 matrix sheet, for a 2x2 system of equation works every time.
Yes. Except last time.
Except the time that, but we made a mistake someplace. I made a mistake someplace because it was supposed to work. Okay? All right? So again, so now tell me, how do you use Kramer's rule? How do you find the denominator? All right? How do you find the denominator? You use the determinant for this, right? How do you find the numerator for the x? You replace these two x values with the constants. And how do you find the numerator for the y? You replace these two coefficients with the constants. Right? And it's easiest to rewrite them. Okay? Now, all of these had positive numbers, so the math was pretty straightforward. If you get some negative numbers in there, you have to be careful. Just like when we were doing integer arithmetic, I'm going to throw in the negatives because you have a chance to make a mistake. Okay? All right, so let's look at problem 3 on page 124. All right? I'm going to bring this over here so I can write it easier. 6x minus 7y equals 47. And then 2x plus 5y equals negative 21. Okay, now the first thing that I look at is I recognize that these two slopes are different. Right? Because the slopes are different, I'm going to have one solution. Right? That helps me understand that what I'm going to get when I make my fractions for x and y is I'm going to have real numbers. Okay, that's the first thing. So that just helps me. If these slopes were exactly the same, then I either have parallel lines or I have consistent lines one on top of the other. All right, we'll talk about that in a minute. So I don't have that. So now, we're back to this. What's my denominator for the x and the y? How do I find the denominator? The product of, how much is 6 times 5? 30 minus how much? So this is 30 minus negative 14, which will be 44. So this is 44 and this is 44. Okay? Now, how do I create the numerator for the x?
47.
Alright, I'm going to replace these with 47 and negative 21, but I'm still going to have the negative 7 and the 5. And over here, the 47 and negative 21 will go there, and I'm going to use the 6 and the 2. Alright, now we're into some math that we may have to do in a calculator. Alright, so 47 times 5 is 235 minus 21 times 7, 147.
So it's plus 147.
Yep, and two negatives make a positive. So, minus
Equals what? 92.
equals 88.
2 plus.
Oh, 88 over 44.
No, it's. Oh, sure.
88 over 44 is how much? Ghosts. Right? Now, again, because these problems were whole number solutions, it's helping us with our confidence on doing Kramer's rule. Okay? So, the answer for the x is now 2. Alright? Now, let's do the same thing with the y. What is 6 times negative 21? I don't know, but I can find out. I don't get that. 6 times negative 21.
Oh, sorry, I was just writing out.
Alright, I get negative 126
Sorry.
minus how much? 2 times 47, which is 94. Anybody get that? Alright, so now I have negative 126 minus 94, and that's 220.
220 over 44 equals.
And then if you divide that by 44, whoa, I multiplied. I know what the answer is. The answer is 5. Right? So negative 5. So y is equal to negative 5. Negative 220. Alright, so this is negative 5. Alright, now will it work?
Yes.
2 times 6.
12.
12 plus 35 is 47.
Yes, it is.
Yep. 2 times 2.
4.
4 minus 25 is negative 21. So it works. Okay? Alright? So what have we done? Alright, we've used Kramer's rule, right, which is part of matrices, which is usually found in Algebra 3, and we've used it to solve a simpler matrix that's 2 by 2. Okay? Two equations, 2 missing variables. Now, later on in the chapter, and what we'll do next week, is we'll look at 3 missing variables.
Yay.
But what we're going to do is we're going to change 3 missing variables to 2 missing variables and then use Kramer's rule.
Yay.
Because we can do this. Or at least I can. Can you?
Yeah, sure.
Okay, so let's find out. All right, go to problem number 3. Let's see if you work problem number 3 on your paper.
Then we just do the same problem.
I'm sorry, third one down, problem number 5. Okay, and those of you that are taking this, if you'll get to page 124, problem number 5, and work it.